complex analysis. So to discuss about the complex analysis, we have to first introduce the complex number. The complex number is represented by the symbol Z, which is consist of one real part, this is x, and one imaginary part, this is iota y. Here I is the iota, whose value is root over of -1. So in this way a complex number is represented. Now there are many ways to represent the complex number z. Here we express the complex number as Cartesian form. Now it can also be expressed in polar form, so that we have to draw a graph. Suppose this is imaginary axis, this is imaginary axis, and this is some real axis, this is x, and this is imaginary axis, this is y. So if we plot some points, then we get a straight line like this passing through the origin. And if suppose the position from the origin is r and it makes an angle theta with x-axis, then this value is some x and this value is y, this value is y, and this is x. So the complex number z can also be written x is equal r cos theta and y is equal r sin theta. We break it into two components like vector. So the z becomes some r cos theta plus ir sin theta. So if we get this r common, so cos theta plus I sin theta. This is the expression of the complex number in polar form. Now it can also be expressed in exponential form. With the help of Euler, we after some time we prove it. With the help of Euler's formula, we can write it as r e to the power of I theta. So there are three representation of the complex number. First of all, it is in Cartesian form, second it is polar form, and third it is exponential form. Now we have to prove Euler's theorem, which is e to the power I theta is equal cos theta plus I sin theta. We know very well the expansion of e to the power z, which is nothing but 1 plus z to the power 1 by 1 factorial plus z squared divided by 2 factorial plus z cube by 3 factorial plus z to the power 4 plus z to the power 4 by 4 factorial plus dot dot dot. Again we know that the expansion of cos theta is equal 1 minus z square divided by 2 factorial plus z to the power 4 by 4 factorial minus z to the power 6 by 6 factorial plus dot dot. Similarly, we know that sine theta, expansion of sine theta is z to the power 1 by 1 factorial minus z cube by 3 factorial plus z to the power 5 by 5 factorial minus z to the power 7 by 7 factorial, and so on. So if so we are interested to write the right hand side of the equation. So cos theta plus I sin theta means 1 minus z square by 2 factorial plus z to the power 4 by 4 factorial, and so on, plus iota z to the power 1 by 1 factorial minus z cube by 3 factorial plus z to the power 5 by 5 factorial minus z to the power 7 by 7 factorial. So Euler's formula is proved. We have to change this theta to z so that the expansion becomes correct. Now we have to find how can we get the square root of a complex number. Square root, sorry, determination of square root. Square root. Let's suppose square root of a plus ib is equal x x plus iy. Let's suppose this is square root of a plus ib is equal x plus iy, providing x and y belongs to real number. Now a plus ib whole square becomes equal to x plus iy, sorry, a plus b, both sides squaring, by squaring both sides we get a plus ib is equal x plus iy, x plus iy whole square. If we expand this, then we get x squared minus y squared plus 2ixy. So this is real part, this is imaginary part. So a becomes equal to x squared a becomes equal to x squared plus, sorry, minus y squared minus y square, and b is equal to xy. Now we are interested to find out x squared plus y square whole square this is equal to x square minus y square whole square plus 4x square y square. This is equal to a square plus 4, so this is equal to b square. So taking square root both side, x square plus y square is equal root over of a square plus b square. If we add equation 1 and equation 2, we get 2x square is equal a plus square root of a square plus b square. So that x will be equal to a plus root over a square plus b square. This. Similarly, y can also be determined. Similarly, putting the value of x, y can also be determined, so that we can get the square root of a plus iv.